So in this video, what you do is want to apply the unit of dimension. The last video we didn't delete this. We talked about how we represent each of these physical quantities using their dimension meters, right? So what we want to do is to actually check if this equation is correct. Because from the example says a professor puts 2 equations on the board. And these are the 2 equations. So show that the equation 1.1 and 1.2 is dimensionally correct or not correct. Now I took this from the textbook from Physics 101 textbook. I think the textbook was written by a professor from UNIB. So I think most schools will have been that. I think that's just a good because I need to see the hand. Now, firstly, to start with the first one we have here, which is the 14 plus 8. Now we need to break down every of the physical quantities we have here to their various dimensions. Now we know this formula. This formula is motion formula, okay? This is final velocity, this is the initial velocity, acceleration, and what? And speed. So now we know initially that velocity is distance over what? Over time. That is L over c, right? From the last proof engine, I talked about a conversion process that length is the standard code in physics, okay? So this velocity is just a difference in those standard velocity and initial velocity at c, right? So we should repeat L over what? C. That is distance over what? Time. Time is represented by capital and c, and this is represented with capital and m to one length. Plus, we know acceleration is velocity over time. So I will know velocity over time. This should give me L over c all over velocity in velocity L over then all over c, because if you remember, if you recall, acceleration is velocity over what? C. So which means I need to have my L over c, then this t that is it on that I are seeing things, plus my what? C. Okay, so this is clear now. So you see there that L over c is equals L over c plus. Now, what happening? This thing, we can rewrite it as L over c divided by c, right? Times the c we have here. Okay? So this should give me L over c equals L over c plus. Now, at the initial side, we'll change it because L over c times 1 over c times what? C. Then if you look at the bottom here, there's t times of there is t. This is multiplication and cancel that. So both things goes out. So I should be having L over c equals L over c plus. So it's simply guys are 1 times m is n all over c. Now when you look at the dimensions here, and you see that the same thing that is on the left hand is same on the right hand side. Basically what I just see is when you add 4 of this dimension that I'm saying to give you this same dimension that's at the left hand side. So from here you can say it is correct. At least all sides they all have the same dimension. Okay? So we have the second question there, which is x equals b over 2a. Okay? So this is distance x. The way you see x under any motion formula, we know it's a distance. Velocity is what? Distance over time. Acceleration is velocity over time. So from the first question, we already know how to get each of these things. Okay? So I know my distance is L, right? Equals velocity is what? L over c. So I'll bring this to table. So that's 2 times acceleration is velocity over what? C. Okay? So I can say L is equals L over C. Now, I want to introduce, when you choose intuitional science, the what is active, top goes to the bottom, right? So I should be having C over 2 V, right? So this should give me L over C times. From this place, I can actually eliminate, but let's go for that phase. So this should be C all over 2 times. We know velocity is L over C, right? So that's L over what? C. So from here, I if I just eliminate directly, so I can eliminate the both T's here. So L is equals L times this should have been 1 all over. Since this true was better, that's be like 2L over what? C. Now, in mathematics, these are all reciprocal. So if I want to remove this one, what I don't think this in fact was in bottom, both of them. So this should give me L times, okay, C all over C what? Then I to see here that L is equals L same plus L times C all over 2 what? N. So it implies L cancel here. You can see here that L is equal to what? C over 2. Now this one can be taken out and let be 1 up for it. Now you see that L is positive. We know time is different from length. So this shows that they are dimensionally wrong. Okay? So it means this is wrong. Now this is how the proof if any equation is actually correct. So this shows that this equation, this first equation, is very correct. Which is it's a correct equation. If random equation is not correct because the dimensions are what? Not the same on both sides. So the sides of the equation are not equal. Okay? So we can write this, it is have a straight line here. And that shows that it's not what? Not correct. Alright, so I'm going to take another portion from the textbook again. So I'll just erase the board. Alright, so now on the board, we have a more complex question right here. Now, the question says, assume that the following plastic tube per second is given by the equation V equals K mil raised by X R raised by Y, or the rapid change in pressure, that's P, divided by L, which is called surface systems. Burst the mouth, said. Okay. Alright, so we have a more complex question on the board. Now, one thing there is that they are asking us to look for X, Y, Z. Let me read the question. Assume that the volume feed passing through the tube by a second is given by the equation V equals K mil raised to power X R raised to Y, or the bracket change in B, that is pressure, divided by L raised to power Z. Okay, find the value of X, Y, and Z. Hence, or otherwise, show that V is equals to K R raised to power 4, changing pressure divided by L. So now from solution, we'll take each of the physical quantities and actually represent them in dimensions. So we note that from the question, it says that this is a rather volume per second. Okay? So volume per second should be, we know volume is length times length times length times length times breadth times height times 3 of them is density. That is, when you multiply 3 of them, that should be raised to power 3. families divided. Sepals is what implemented with last time. Okay, so we are going to be a little bit fast so that we can meet up with make operation. Now, this word new is tangential stress over velocity gradients. Okay. Now, what I'm not treating is that stress is force over area. Okay, was it tangential stress? Is it as force over area? I'll look for step A, right? That's M. Acceleration is velocity over time, right? And velocity itself is in this should go over A length times breadth. I mean, that's the length times length. Actually, there is perhaps C. I mean, exactly. Okay. So now, velocity itself is distance, which is L over time, then all about this time that is here, divided by area per C. So now when you look at this, you see that as we have it N, then this L here multiply this N. Okay? Or we can just do it the slow method. If, for example, I have N over C now divided by, I'll break this in short sentences when I say, so that's the kid. N is part 2. Now, if we have N over any times, now, this actually changing the pure sign to the multiplication becomes 1 over C, all over N is not C. So this should give me N L. So this is C square. I need to write it upward. So after multiplying C times T is T raised by C. So I'll write it to take it to the top. That will call raised by minus 2 all over N raised by. So if you look at this, L can cancel out. So I'll be having M C raised by minus 2. Now when we cancel that will be L out of this place to remain just one N remaining. Now since the L is at the bottom, just like what I did here, since you have C squared, once you take it to the top, it's going over T squared. So that'll be C raised by minus 2. Same to here. This is just like 1 over N. So for us to rewrite it, so that'll be L raised by minus 1 since it's not 4 over N. It's not L raised by 2 sorry. Now, this is for the tangential stress. Then let's look for the velocity gradient. Velocity gradient is just velocity divided by r. So velocity gradients, just velocity over r. I already know velocity, right? That is distance L over what? Time all over. This r we assume here is distance, not r is distance. Eh? So that's M. So it should be L over T divided by R. And it should be N over T times 1 over N. So M cancel N. I just have 1 over T, which can be written as C raised by what? Minus 1. Now, so it means we're in this case now, will now be N C raised by minus F minus 1 all over C minus 1 because it is tangential stress divided by velocity gradient. So if you look at this from indices here, remember, whenever we have two data and they are divided by their raising something in power, we can take all of them in indices. This is like division. So we can rewrite this thing as M, have 1 over C, we have minus C here. Then this sometimes also minus in brackets. This is the bit I'm breaking down in bracket. Minus, just a minus is that we can differentiate the minus. That's minus 1. So that's all. See, we have 2 of it here. We take 1 of it. So first part on the minus 2. Then our addition sign brings this minus here. Then open bracket minus 1. Then we are still about N being minus 1. So I drew like this. This is N. C. This if you open the bracket, that we see 1 minus 2. Minus times minus that equals 1. L square minus 1, and this should give me N minus 2 plus 1 is like saying 1 minus 2, and that's it, minus 1 L square minus 1. Okay, so what's the dimension for mu? So this dimension, before this one is the arrow raised to power y in centimeters. Arrow raised to power y in the centimeters, and because arrow is the distance. Arrow is the distance. So therefore this one, pressure is force over by area. So if I exert my arm on this board, it's my force exerted over the area that is exerted upon. So that should mean pressure is force over what? Area. But I think when we did this, I got this force over area. This was the dimension we got. So you could just work with that. Okay? And this shortening the process. L square minus 1. Okay? Then L as mission 1 is head and date. Okay. So now for me to go on, I hope here you all understanding the just now. What if you actually don't understand and if I'm too fast, because I'm trying to be a little bit faster so that we can cover all this question during a short time. So you can rewind, forward, back, and check all what I've been doing. So we've gotten K is a constant. We don't mean it's okay. It doesn't have a dimension, it's just a number. What's in green, what's in arrow, what's in P and normal A. Okay, then volume per second. Volume per second. We got it as let's see, volume per second. We got it as the sky is for TV. I'm just bringing it back to that. We are going to compare, we can go straight. So volume per second has still small minus 1b. Volume is L raised to power 3 at its length times weight times height as length times weight. Then for per second it's divided by t. When that t now, so you take it to the 12 and be raised to about 9 minus 1. So if I'm to write down this equation with my dimensions, what I'm seeing is L raised to power 3, C raised to power minus 1 equals K is taken out, denominator is equals as, then what my mu was N, C raised to power minus 1, L raised to power minus 1. Now it raises H to the power K, so that's powers by X dots. Arrow Y, that's N Y. Then everything in brackets G. Pressure is M, C, with by minus and F another 9, all over N D, all raised to power 6. Okay, now we can break up these brackets, okay? I'll open up on the brackets. So this should give the L because M raised to power. Now since the bracket is open here, each of the letters we take up S as power. So that L is power X. So S will almost carry this minus 1, we have it use power minus what X. L also minus what S was S times 1 minus X. For L, Y, dot. I've looked at this places in the N. Now if you are opening the bracket, then we multiply each of them. That's what we did for this one. Same thing. For N was upon Z, C is about minus Z times minus, we have minus 2 Z. L minus what's Z, because Z times 1 Z. All of my L is power what's Z. So this is L is power 0, C is power minus 1. Now if you look at this place, N we will see X, C is power minus X, L is power minus X, dot L which power Y, dot M raised to power Z, C is power minus CZ. And look at this place, this is L N, it L is power Z. This is L N, right? I'll just take one of these from indices L. They write out the minus Z paste. Okay? And look at this, this is a division sign. So indices minus. We are combining two numbers, two or two letters. We see it like this. For example, I have X is power in Y, X is power in Y. as x is by a minus b versus equations and b does something this is 3 we go. It as a sentence here. So this should mean minus c minus a, the implication side minus something which on minus then by set. So I go for right together, that should be minus q z plus 5. Minus 5 minus z minus z, that should be minus 2 z, right? So L 0 per minus. So now the next thing we need to go, if we want to get the value for x, y, and z, so what we need to install compare by comparison. So before that is place, n is over there. What it basically means is that n is 0. Okay, because I can write n in the n raised to power 0, L 0 c minus 1, and it's correct. Okay, because m x c minus s l minus x dot l y dot n z t minus z l minus c z. So in this case, what I can do now is to just compare. And so I'll compare all the values, all the power for them, all the power for t, all the power for n. Now, because y, since the left hand side from this side here, the equation means whatever is on the left hand side is into the right hand side. So we can see by comparison that the comparison of 0 is equal to all the power for m. M is here, is z and s close. Now, since this is multiplication, then this is since you have two numbers there based on the power to the power and they are multiplying themselves. Definitely, you can see the power is a adding up to those set since is equation 1. Now, we'll go for C. So if I go for P, so this is for the N. So we can go for, you would therefore for N, this was, that's what we would M N. So for N, you can see that it's just be still equals L, the first L there is minus x, then the next L there is y, plus y as positive y. The other L there is minus full state. Get? Then let's go for C now. Okay. You see that? See here, it shows the power of minus n equals, see the first thing there is minus s. The other thing here is minus 3. Say, so we just have to screw over C's. So this should be put equation 2, this should be equation 2. Now, what's in the two equations by comparing the powers? So since we know that the base letters are equal, definitely the power ought to be what? Equal. So basically all those things to request the power by comparing. Now, if you look at this equation, I can see solidly, I can add up equation 1 and equation 3 and get the value for x and y. The contents equation I get, sorry, for x and c, and come to this equation, I get the value for what? Y. I will end that. So I can say the equation 1 was 3. So I know 0 plus minus 1 3 what? Minus 1 equals 0 plus anything is safety because I will have minus x and plus x. So if I say minus x plus x, what should that be? It's 0 plus next. Say s is x, and that's 0. Okay? So that's 0. So now z, that's equal z plus minus 3 plus z plus minus 3z. For minus 1 it equals, is like saying minus the plus side is minus 3 minus z, so we have said minus 4z. And this should mean minus what? Z. So it means minus 1 to plus to minus z. So minus can cancel the minus on the other side. So it means implies z equals 1. Okay? So we're getting z. What can we do? We can go back to equation 1 and say put the value of z for equation 1 and get the x. So from the question line, what we have there is 0 is equals x. Z is 1 plus 1, right? So it implies if you take 1 to 1, it's 0. That's relatively like about something as x equals minus 1. So now we have Z equals 1, x equals minus 1. So let me erase this part so that I can publish again. Alright. So now we have button base, button Z, button down to get to y. So from equation theory, and this theory, people, whenever I see x, I put multiple x. Now, don't forget it's minus c. The minus is here in bracket. If I know that's minus, I want to put it inside the bracket, I will know that the minus will be black. Minus 1. So what's the next one to is 9? Then minus triple a bracket. Z is what? 1. You get? So 3 is equals minus and minus 1 plus y minus 2, but 2 side 1 is 2. So 1 minus 2 minus 1, right? Well, the best simple to let me not take anything to the left hand side and correct like this. Correct like this. Okay? Correct like this. That's notional first. Formula. So y equals to, so the things are the left hand side of it. If I bring from this way to be plus 2, if I bring 1, pressure the question sign, weight minus 9. So this should give me 2 plus 2, 5, minus 1 out there, 4. So S equals minus 1, Y equals 4, and Z equals 1. Get. So this are the period letters, the actions. This is how to get 0 out on it. Now, they said answer otherwise show that B equals this. But all we need to do is to just to build the values now compose this video and try and pinch the values and got into this equation and see if my head things in on like this. Okay? So now I'm seeing. Alright, so V equals K R Y, we bracket Chelsea with K all over N by C. For wherever I see K, wherever I see X is minus 1. So this is the new versus about minus 1. Arrow Y is all 4, P spot 4. In brackets, change it the heat with my N, which the power what said as 1. So this should give me 3 equals K. We is power 1 and R is on 4. So if you open the bracket in this one, it's something that's changing in the N. Okay? So what will happen now? These guys are the bottom. Everything is multiplying here. So we have K. It's power minus 1, R is power 4. Changing P all over N. Now, we let's talk about this mu is power minus 1 means we want to write it normally. It will be 1 over in me. So that will make the mu equal back to the bottom. And that should be made C R is about 4. Change it with E or over mu and well, is I show these equations there. And equals K R is 4 turning B all over mu there. Okay? So now if you don't understand it, can slow down the video, rewind the video, watch it, take out the time to make sure you understand anything. And if you can understand anything that is here, and we know how to work through this project. Now, you can say the question is non-yes, but if you understand what's going on, it's super easy down and goes free. It's interesting, right? So I'll see you in the other video, but this is all for my past, okay? And don't forget to share the video. If you like this video and as never to also click the like button on this video, share it to your friends. Remember this, you have fun as well, students like you and your friends also. So I mean to help me achieve the goal of helping the little students, okay? sharing income. Thank you and God bless you. See you in the next one.